map for the laboratory to become a premier physics institution in the country. Sir Krishnan was born on 4th December 1898. Thus, we are celebrating his 125th birth year with a lecture series remembering Sir K.S. Krishnan. Today, we have a lecture on establishing a platform for solution engineering, redefining innovation by distinguished Professor Suresh Kumar Bhargav from Royal Melbourne Institute of Technology, RMIT University, Australia. He is also an academic professor of AcSIR. I request dignitaries to please come to dais. Ladies and gentlemen, put your hands together to welcome our today's guest of honor, distinguished Professor Suresh Kumar Bhargav, Professor Venugopal Achanta, Director CSIR NPL, Professor Ajay Dhar, Director ACSIR, Professor Reena Sharma, Chief Scientist CSIR NPL and Coordinator ACSIR. Now, I request Mr. Harshit to honor our guest, distinguished Professor Suresh Kumar Bhargav, with a bouquet on behalf of ACSIR and CSIR NPL. Thank you, sir. Thank you, Harshit. Now, I request all the dignitaries on the dais for the floral tribute. Thank you, sir and madam. Thank you. I request Honorable Director CSIR NPL for his welcome remark for Sir K.S. Krishnan. Sir, please.
Professor Suresh Bhargava, Professor Ajay Dhar, Dr. Reena Sharma, and all my colleagues, students in the audience, and those who are online. So, on 4th December, we're supposed to have this celebration of 125th birth anniversary of our founder, director, Dr. K.S. Krishnan. But it was a local election day and all that, and then we had this honorable speaker who was due to come, so we thought like we'll club the two and have it as a pan-CSIR event where our colleagues from sister labs are also watching this online. So this is a momentous occasion. So we started this celebrating given by Dr. T. Ramaswamy, who is the chairman of the foundation, Memorial Foundation. So he graciously agreed last year, and today we had one more stalwart speaker for us. So we hope like we can continue to remember our founder who has set these excellent facilities for the nation and make sure that though this is always a contentious issue that NPL is a physics institute, is a metrology institute. I keep saying that we have three pillars. We have metrology, material science, and environmental sciences. We are leaders in all the three aspects, and we try to do our best our founder has done his own significant contributions to the field of material science, especially in crystallography. If you look at his publication record, like I don't know, 1/3 of his publications are in Nature, right? So, I mean, times were different, all that, like, but still, we strive to publish one Nature in our career kind of thing nowadays, in spite of having so many Nature and Nature sister journals, right? So he had 45 Nature publications, just to give the number, right? And he also contributed to the discovery of Raman effect, right? What he's known for is his ingenuity to make experiments, to develop experimental setups and then do the measurements, state-of-the-art measurements with minimal resources, right? This is something which we should get back. We were talking a while ago that nowadays we all are pampered with resources during the last, 10, 20 years ago. But nowadays we are again back at the place where funding crunch is there, where we have to reinvent ourselves, where we have to learn to make our own setups with reduced resources which we have. So this is what brings the ingenuity in us. So we have to make use of the frugal resources and do cutting edge research so that like we become competent, we become well known in the society as well as in the scientific community across the world, right? So this will be a tribute. This is the best tribute what we can give to our founder, who thrived, who actually practiced this way of doing research, right? Setting up things, world-class facilities with minimal resources, right? I really look forward to this, to come back to this great institution as a tribute to our founder, right? Let's listen to today's talk, and which is also directly related to the mandate of CSIR. As members of the CSIR, we're also serve the industry, but not just in metrology, but there is a lot more which we can do. And what we can do, we'll listen to today's speaker and try to inculcate in our day-to-day research activities. Right? I once again welcome Professor Suresh Bhargava and all of you for this lecture today. Thank you.
Thank you so much, sir, for your inspiring address and valuable message. Now, I request Honorable Director AcSIR, Professor Ajay Dhar, to felicitate distinguished Professor Suresh Kumar Bhargava with a memento.
Another one. Thank you very much.
I also request Professor Dhar to felicitate Director NPL, Professor Venugopal Achanta, with a memento.
Honor the director.
Thank you.
Now, I request Director AcSIR to address and introduce our guest, distinguished Professor Suresh Kumar Bhargava.
Distinguished guest speaker, Professor Suresh Bhargava, Director, National Physical Laboratory, Professor Venugopal Achanta, AcSIR NPL Coordinator, Dr. Reena Sharma, AcSIR students, faculty, and my dear friends. It's indeed a great privilege for AcSIR to jointly organize a special lecture to commemorate the 125th birth year of Dr. Sir K.S. Krishnan, who was also the founder director of this prestigious National Physical Laboratory. At this moment, I am reminded of a very famous quote of Sir Krishnan, and I quote, "This elegant generalization is mathematically very appealing, but physics means facing facts. You should take up case by case." This is a very famous quote of Sir Krishnan, and this just shows what a great experimental mind he was. And that what later said, NPL said that we should inculcate such experimental facilities, not using very expensive equipments, and try to, repeat those experiments, what can be done by very expensive machinery and so on. Fortunately, to commemorate the 125th birth year of Dr. K.S. Krishnan, we have an experimental researcher par excellence, Professor Suresh Bhargava, who would deliver his lecture entitled "Establishing a Platform for Solution Engineering Redefining Innovation." This lecture is being live streamed at all 50 locations of AcSIR across India, including all CSIR laboratories, also on Facebook and YouTube. Professor Bhargava, I'm sure most of you must be aware that he's a world-renowned scientist. Nevertheless, I will just highlight some of his very, very important scientific achievements. In 1990, Professor Bhargava got his PhD from University of AcSIR and started his academic career at RMIT University in Australia, where he established a state-of-the-art research center called CAMIC, standing for Center for Advanced Materials in Industrial Chemistry, which ultimately, as of now, becomes the world-famous material science laboratory in Australia. This center has developed new products and technologies that benefit society and produced real-world graduates. Professor Bhargava has authored over 600 highly cited publications with an H index of 79, 1 book, 16 book chapters, 12 patents, and delivered more than 150 keynote and plenary lectures all over the world. Professor Bhargava is currently holding the distinguished professorship of 6 top-tier international universities. Interestingly, he has also been the founding architect of Australia-India Strategic Research Fund, which funds projects all over India. And this is the 15th year of this in operation. And I remember while I was at NPL, Carbon Group also was a recipient of huge such funding, the one I talked about. More importantly, Professor Bhargava is also the founding architect of AcSIR RMIT Joint PhD Degree Program, which currently is in its 6th year of operation, and more than 120 AcSIR students have been registered so far. And many of them are from NPL here. Recently, this year, Professor Bhargava was conferred with the highest Australian honour, the Member of the Order of Australia, in recognition of his scientific achievements. As a winner of some of the most prestigious awards, including the most coveted award in engineering, the Chemica Award, he is the first RMIT researcher to receive the RMIT Vice Chancellor's Research Excellence Award twice. He was honoured in 2014 with the P.C. Ray Chair by the Indian National Science Academy, and also has received honorary DSc degree from Rajasthan University, presented to him by the President of India. An inspirational figure to many, he pushed boundaries and developed innovative ways on how universities should work with industry, what we have been debating in India for a very, very long time, in creating jobs and changing lives. So this thing which we have been debating in India and many universities and institutions about the industry-university interaction, probably he will give an insight in his presentation. I now invite our distinguished guest to kindly make his presentation. Professor Bhargava, please.
You have to help me. Yes. You want to put in there. Thank you very much. You're a student here? No, sir. Okay. This will go forward and backward. Okay. Good afternoon, everyone in the audience. Namaste. I still speak Hindi. Shri Vinu Gopalanji, Director of the Laboratories, Professor Ajay Dhar, Professor Sharma, and also I saw Arpita somewhere here because she was my first contact point in the AcSIR when I established the AcSIR coordination. So Mrs. Arpita Sen, she'll be here too. So let me allow to say one thing very clearly, that fundamentals is the heart of innovations. Fundamentals are the heart of innovations. Without knowing and discovering those fundamentals, what we see today in the world was impossible. He is the man who contributed in the fundamentals. He lays the ground, not only the NPL ground, he laid the ground of those fundamentals which is producing, which is making the difference of the life of many people around the world. So my humble homage to Professor Krishnan is there too. Although he was trained with the C.V. Ramans and Fellow of Royal Society, of course, is in there those days. And amazing thing is there on those days where instrumentation and technology was not that advanced. Still, those scientists could make the difference, could make those discoveries which were unknown. See? I mean, this is the message to the students, you know. The limitation is not what you have. The limitation is your attitude, what you want to do. My theme today is very different. My themes today is a solution engineering. And you will ask, what is it? We have a civil engineering, we have a chemical engineering, we have a mechanical engineering, we have electronic engineering. What is this solution engineering? What is this solution engineering? And I will try to explain you what is solution engineering. What happened today in the past in 125 years when the science has been discovered, now the community is asking from the scientist, what is the purpose of your science? Is it just publishing the papers? Because when you publish the paper is read by your peers, right? Read by peers. Then the peers goes on and then continues. Probably one day you believe, may not come true, that your research may be translated into a real service to the community. What do you see today? Many of those peers who developed all those sort of things, they succeed because the fundamentals were there. But today's world, when India is facing 1.4 billion population, the world is facing COVID, the world is facing so many challenges. The demand is coming from the world is how you translate your research into the real innovations. Then the question comes, do we really understand the meaning of innovation? Because the world is using different type of, 20 years ago, I don't know what the H index is. Now everybody, every student, every lecturer, every scientist know what the H index is. 20 years ago, think about it. Do you know? Did you hear what is H index? Today, so new innovation of terminology appears from the West. Right? They defined how you measure your scientific output, how to measure your scientist outcomes. There is a difference between output and outcomes. So those subtle differences, probably I will take your journey in there. But before that, I would like to acknowledge, this is the notations in Australia that we finally say sorry to those tribal peoples, the native peoples. This is the acknowledgement of the government. This is the acknowledgement by every foreign natives in that land that we acknowledge, or RMIT University acknowledge, the Wurundjeri peoples of the Kulin nation as the traditional owner of the land on which the university stands today. RMIT University respectfully recognize elders, both past and present. But tell you the truth, India moved one step ahead, isn't it? Who is your president today? I don't know what is happening, but one thing I know, that India is moving such a fast speed to the changes, which is making a highlights in the world. He's not talking about it. Here we are talking about it. India is doing about it. And that makes me proud that I'm also a born Indian. Although I left nearly about 35, 36 years ago, this country. But I was one of you. Not far away from Delhi. Not far away from Delhi. And I am honored that both Professor Krishnan Lal, your director as well, and me, both educated in Meerut, both came from Meerut, is in there, and we continue our journey. Of course, through challenges, is in there too. And that's why I usually say over there too, that the great peoples like that, like Professor Krishnan is there too, they are not born in the maternity ward, right? They tried. That's why I was talking to your director's office today. They tried every pieces of their experiment, design it properly, and then discover. They do not wait for a grant. No. Scale has changed. You need a grant today. I'm not saying you don't need a grant. You need a grant. Of course, you need the money to buy the instrumentations. You do not want to scratch what was stretched 125 years ago. Clear. No problem with that. But I'm talking about the attitude. The attitude was very different. Attitude was there. I have to discover. I have to do it. The passion was different. And that makes the difference. Let me share with you. You all know that. Inventor of the Raman scatterings, along with his mentor C.V. Ramans, who received 1930 Nobel Prize of Physics. Developed the Krishnan Banerjee method for measuring the magnetic susceptibility of small crystals. You all know that. To this day, his research published in Natures, as Professor Dhar says, is in there. Terrestrial magnetism, atmospheric electricity, and other top physical journals remain the most definitive scientific reports. 1954, he was awarded Padma Shri. Over there, 1958 Bhatnagar Award, Fellow of the Royal Societies, and most importantly, in this lab, where I stand, where you sit today, he was the first pillar. He was the first director of the university, of your laboratories there too. It's interesting actually that when I was coming by car to your laboratories, and it was on GPS and the loudspeakers, the speakers there too, and when I was turning there, now you take turn to the K.S. Krishnan Road. And I said, wow, I'm giving a lecture of K.S. Krishnan. He said, no, it's a K.S. And GPS was keep talking to me, take a turn, left turn to the K.S. Krishnan Road. See? The benchmark has been established by this great scientist. Now the turn is yours, guys. You have to follow it. You have to look your dreams into his foundations, what he has laid down over here. What he has provided to you, what you see the NPL today, he was the first foundation, first pillar laid down on these laboratories over there. Laboratories are not known by their buildings, trust me. Laboratories are not known by their infrastructures. Laboratories are known by the pupils who serve that laboratories. Laboratories are known by the scientists. If you have the scientist like him, scientists, other directors, or other scientists over here, the laboratories will be known by them. And that is very important. You, scientists, or as students, follow the same pathways, isn't there? Now, here comes. The modern technology is modern there. Because what is happening today in the world, and watch it, listen my words very carefully. In next 5 years, the disciplines demarcation will disappear. There will be no disciplines. Here, there is only one discipline's solution. Do you have a solution of the problems? Because what is happening there, science has to work with the engineers to make dreamlines, technologies. And technologies compete in the world. Which one is the best? China, Japan, US, India, Germany? And they all use the scientific innovations is in there too. So that's why I'm using this word, because as a scientist or as a young student, you must understand the difference very clearly. The creativity, they are the same words, you see. The creativity is coming up with the new and useful ideas. That is creative ideas. Innovation is the successful implementation of those ideas. See the difference. The business sometimes or the institution, we need both. We need both creativity and innovations. That's it. Creativity does not lead to the company's inventions and growth. Innovation does. I mean, you work in the industries and you say, I got an idea. You say, very good. You got ideas. Where is the product? The real impact will come when the product is really discovered. When the creativity has been translated into innovations, into a product. Today's students, if you want to become innovators, and why not? Why not? When you're doing a PhD, you must understand one thing. You're not doing a PhD for your scholarships. If you are doing a PhD just for the money, for the sake of just passing 3-4 years, you are the most idiot person in this world. Trust me. Most idiot person in the world. Because reason is that the life is divided between the 2 points, B and D. You know that. And this is the best part of your life. You want to compromise just because of these scholarships? Just because of that? Your best life of your 4 years? No. No. You want to make best use of it. You want to see what the best I can do in these 3 or 4 years. You want to see, is my dreams, what do you see the dreams? Is it my dreams? If it is not your dream, get out. No problem. Do something else. What do you want to do? But don't play with your best 4 years of the life. Don't play. Don't play. That's what I'm telling you. Don't play. We as a scientist, we as a collaborator, we as Ajay, we as AcSIR, we as NPL and RMIT, we have provided you a platforms for innovations. We have provided you all the opportunities where you can explore your potential. And if you still don't follow your dreams, if you really want to become a scientist, well, I was right, isn't it? You'll be idiot. If you don't follow your things, that 4 years just for a scholarship, the money, no. Here you can say generating creativity means allowing people to think outside the box. That's fine. And go against the sometimes out of the trends in there too. If you let bureaucracy is the totally enemy of the innovation. Trust me. I face all the times till today. Because the reason is that innovation speeds. Do you know really that 4,000 apps are downloaded in this world per second? 4,000 apps are downloaded in this world per second. Technology is competing with the thought of the mind. They both are running the race. As you think, technology is moving ahead. The time is different. This science and technology time is very different. Very different. And we have to move with the time. And when I talk to the solution engineering, it is mine to the marketplace. When you can say, yes, I have a product. Now I have to test the market. Because the market needs a complete solution. Is a sustainable solutions. It needs a solution which you can sell to the customer. You have to provide the troubleshootings. You have to provide everything. You have to bring a lot of discipline into it. Solution engineering sometimes refer to the IT product. No. IT is just a one component. It takes all the discipline into it. And when you combine all the discipline to find out a complete solution, wow, that's the product is the difference. Nowadays, you know that the definition of business, what I heard about 10 years ago, that business exists to make a money. If you don't make a profit, business collapse. Very simple. I was the board of director of Aditya Birla Groups for 9 years. And I was listening to Kumar Mangalam one time, he was talking, is there too. If you cannot translate your $1 to $3, you don't know the business. You see the modern definition of business now in today's world? The business exists to make the difference. If you can make the difference, you survive in the business. Customer will follow you. Why the iPhone 14 is so popular, there is a queue in the night? Why? Why not the Samsung? Why not the LG? Why not the other product? Because you know that product made the difference. There's a queue in all over the world when the new product is coming up. There is already perceived things that something is different. So definition of in business has changed as well, which makes the difference in your life. And that makes the difference which is visible clearly. Wow, that's it. Isn't there too? So that's why I'm saying collective intelligence works. Nowadays, the power of one is no power at all. That's why we need all the disciplines to work together, to innovate a product, to innovate a model, to collaborate together to make the difference. So theory is clear, to make the difference. Solution engineering, I will talk about different examples to you, how you can do it. I will not talk about it. I will show you my own examples to you. With a humble request, because I know what I'm doing. So you can judge it instead of taking the example from literatures. I have published not 600, 800 papers now, right? We published, my group published, my own group published nearly 40. You can check on the Google. I mean, there is nothing hiding there. Everything can be checked nowadays. Digital technologies talk about it. So there is no hidden things as well. And I will show you very clearly what authority I got to talk to you in such a way which is guiding you towards the innovation. That's the one thing. Second thing is there, collaborations. But collaboration saying it's not that easy. It's not that easy. Collaboration means share. Collaboration means assist. And most importantly, collaboration means trust. If there is no trust, there is no relationships. Whether it's a science or whether it's a personal life, you know it very well. Now when you sit down the two tables to the collaborate, we are collaborating with this lab, and everybody is thinking, what is for me, what is profit for me, what is profit for me? Well, the foundation is very weak. Because if you think about what is me, it's not going to work. If you think about we, it will work. These are the subtle differences. This is the certain mindset. You think about it. If you want to collaborate, if you want to have a relationship with somebody else, you have to trust. If there is no trust, there is no relationships. There is no relationships, there is no team. And there is no team, how you can get a success without team? You have to build a team. Isn't it? That's why I put share, assist, trust and support. And collaborative research holds the key to solve those global issues which world is facing. There are many issues, are common issues. When I see about it, there is a COVID-19 came, and there was a whole world is doing their research and everything. The maximum sharing of the scientific research came out that time. Only, right? And then as the situation get a little bit better, and the same story. That's mine, that's a pharmacy, that's mine, I will do that. They do not consider that is the human. We have to serve the human community. That is the bottom line. And same goes to the science, whether it is a carbon dioxide issues, whether it is a measurement issues, whether it is any issues which can serve the community, which can serve the pupils. That is most important. And everybody says that, but how many people does that? That's the difference. And that's why I'm telling you, maybe they don't do it because they don't have a formula. They don't do it because they don't have any mindset. They don't do it because they need leaders to do that. But fortunately, in your country, in my motherland, yes, those leaderships I see quite often. Nowadays, this India is very different. When I left India, and this India is very different. clearly I say, this is different. Let me share with you, which is with a humble notation. Who am I? This is me. 3 decades of my life has gone to the 50-50, 50% industries and 50% academia together. I serve many industries. I serve the biggest resource industries. I serve on the board of directors as well. So I know what they're thinking about it. And in academia, you can say, second to none. Yes, I publish in Natures. I publish in all those journals, of course. All those sort of things. That is a criteria for all those sort of things as well. No problem with that. But I'm saying to you, and in academia as well, we got that too, is in there. And most importantly thing is there, that what I say is there, that yes, I'm proud to be establishing a strong relationships between the down under, Australia, and my motherland, India. You know why? Somebody asked, Suresh, why you are so passionate about your motherland? You left 40 years ago, 38 years ago, and all those things. A lot of people, when they go to Canada, America, US, and there too, they usually think the weakness, that what was the weakness there when we left. No. I was in Dhaka just a few days ago, and I heard the Mujibur Rahman quote, and that touches me very well. I quote it to you here, there too. And that applies on me as well, that my strength is, I love my people. And my weakness is, I love them too much. That's it. That's how I'm here. Okay? So that's me. That's you can see. Yes, with this qualification, as you can see over here, yes, I can talk to you. I can talk to you about solution engineerings. Yes, I can talk to you about innovations. Yes, I can talk to you about those changes, the mindset, what you should try yourself as well. Is in there too. So what I did, I show you a couple of examples, clear-cut examples in there too. Okay, we established, when I started there, I established, as Ajay said, that I established a center. It was a group, growing, and become a center. And in this center, what I did, I brought many disciplines together, including engineers, many engineers. The difference was there. These scientists, most of the times, they do not sit in their separate divisions office. No, they sit in the same hall. They talk at least 2 or 3 times, at least 1 time a day. What are you doing? So they are keeping an eye on each other. What are you doing? What is the things? I can do it. I can do it. I mean, there is a lot of discoveries has been made by the centers in a 10 or 15 years. But I will show you one simple examples. Now we're talking about science. We're moving out. We're coming out to the science straightway. Is there? And then I show you these things. For examples, I love gold. I love gold. True. And I tell you the truth, who does not love gold anyway? Anybody in the audience who does not like gold? Everybody loves gold, isn't it? Particularly ladies, they love gold. Who doesn't love the gold? Everybody loves gold. But I love gold. And I never wear the gold either. Never ever. Even you can see there's no ring. Never use any ring at all. Even there too, never ever. And what happens there, I tell you a story over here, is there too, that what happens over there, that I joined the ANU, Research School of Chemistry, when I coming from England after PhDs. I do have an honor to work with Professor Abel, who was a great scientist, and also Geoffrey Wilkinson, Nobel laureate, Sir Geoffrey Wilkinson. And they sent it to me to ANU. I never applied. He just sent it to me, parcel over there. So I came to Australia. And Martin Bennett, he was FRS as well, and he says, Suresh, in my groups you can pick up a problems which is followed by the another research fellows, or I can give you new problems, which I don't know whether it's going to work or not work. And he gave me a gold problems, making these gold compounds and everything. And I don't know why, but I accepted that. Fine, I will take this. About after 9 months, I made first of that gold compounds, what he designed for. Bringing the 2 gold atoms in the close proximity is in there. That was his theory. He was thinking there too. Because if you can do that, wow, you don't know what you can do. 9 months later, when I confirmed I got the compound, I rushed to his office. Martin, we got it. And I can't go it. He was a dean. He was a dean of the Royal Society of Chemistry. ANU, RSC, Research School of Chemistry. So his secretary said, no, you can't go. And then I say, all right, I sit down outside. He will come. So when he comes, then Martin, I need your 2 minutes. And then he said, all right, come in, Suresh. And then I say, Martin, we got it. You know the first sentence he told me on that day? You don't know what you discovered today. You are sitting on the gold mines. It was his word in 1983. I'm still working on the gold chemistry till today. I need 2 more lives to complete these stories. The chemistry is not going over. No. So what we did in this one, that I will talk to about in there too. I moved to the molecular engineering and then we go to the gold nanoengineering as well. Gold nanoparticles, you heard about it a lot. So I'm not going to talk about too much. I'm going to glimpse of examples. You can see that how this work has been done. So you can decide yourself that how the innovation comes. I give you the examples on different fields. So the one example is the molecular engineering of gold. Because molecular engineering of gold, when I put the 2 gold atoms together is there too. Gold exists in the 2 main oxidation state, gold 1 and 3. If you have studied some basic chemistry, you know the chemistry of the element depends upon its valency, outermost of valency electrons, oxidation state. You all know that, I'm sure. We learned in the BSc and MSc in there too. Then both physics and chemical properties of that element depends upon the outermost electrons, oxidation state of that element. We discovered a new oxidation state of the gold, gold 2. Gold 2 never existed before. The moment I discovered the gold 2, its physical and chemical properties, I can define it. And then the new chemistry of this element starts in the periodic table. I gave the idea to the periodic tables in there that several new oxygen state hitherto unknown in the literatures can be discovered. So is their physics and chemistry can be redefined completely. And that's exactly what happens, because then I start using those molecular engineering of the gold compounds for the cancer treatment. And those compounds are showing 200 times better activity than the market drug. Is in there too. If you see in there is a periodic table of the medicine nowadays. You know, you go to the chemicals, okay, you have a selenium deficiency, you have a magnesium deficiency, you have a calcium deficiency, vitamin D deficiency, you know, they have elements. And then small potassium deficiency, sodium increase or deficiency. This is the periodic table of the elements. They are all elements present in your body. And in the cancer treatment, this is the common drugs the doctor used. Cisplatinum. Simple coordination compounds has been used for 3 decades. $1 billion business for pharmacy. But the side effect of these drugs is so severe, it can buy sometimes to the patient. Most of the times, patient dies ultimately, but the effect of using that is very severe. I have seen dying my friends from my own eyes. Suffering from this drug from my own eyes is in there too. And that passionate me, what is the use of it? Do you know? 9,948 patient dies every day from cancer. Nearly 10,000. It could be increasing every day. 10,000 patients per day is there. Then you ask a scientist, what is the use of my science? If I can reduce the pain of somebody else, if I can discover something which can make a difference. Important? Theory is very simple, which can make a difference. What is not available? Worth it. Isn't it? And that's the ideas came out there too. And that's what I'm telling you. In the cancer drugs, if you do that, then nearly about 70% of the cancer treatments is still going on using the cisplatinum or platinum-based metallodrugs. We thought about gold. Why not gold? And the ideas came from India. Why? Because the gold basam was used in Ayurveda. Vedana sale, gold basam. My mother used to take gold basam. Ved ji banaya karte the aram se gutti khol ke ye gold basam is in there too. And I was curious what is in there. Sometimes when my mother take it, I also take from the honey in there too. Nothing wrong. And I heard as well that is still chandi ka barak, swarn barak is still आप बर्फी पे खाते हो तो metallo drugs is there, is body accepting it from centuries, but what is the scientific theory behind it is in there. That was the things, and that's why we got there too. We formulated like a molecular designing of that, Then gold anti-cancer agents in there, we can attach with them too. Heterobimetallic anti-cancer agents there too. We did that too. Electrochemical analysis. We did all the fundamental studies of that. We have published nearly about 120 papers, highly cited, top journals. Chemical reviews articles, which is the impact factor of 60, is there. More than Nature is in there. We have there too. And even the most important journal of the cancer, the Lancet Cancer, impact factor is 202. I did not approach them. They approached me, Suresh. Do you have any paper, please? See the difference. I did not ask it. They wrote to me email later. Suresh, do you have any paper? We saw it. You know, your papers going there too. Do you have any paper? Any review? Do you want to submit? So that is the ideas. And you can say gold nanoenzymes. When you discover something, you do not discover one thing. You discover for multi-purpose. Because again, I'm repeating, because that is going to make a difference. Not one, a compound, a drug which can cure 2, 3 problems. Why not? Why not we can discover that way? And that is the whole idea is there too. And then you can see there too. And then you can see that is the molecules, because what I did, gold 2 compounds I made to the gold 2 atoms, created the gold 2, and we discovered that gold 2 is associated with the oxygen containing ligands. Oxygen containing ligands are the drug molecules. I can attach to the gold with these drug molecules. Is in there too. That's why I'm doing it. That's why their impact is coming out. I am not only making them, characterizing them, I'm proving them this compound exists clearly by the single crystal structures over there, and then do it. And after that, you can see a definitely benefit. But what happens, that is the reasons. This paper published in European Journal of Chemistry is there too. It got viral. It got viral in the media straightway. 176 million viewers, 240 media around the globes. All the academies, American academies are showing this work. All of a sudden, that puts us in a, famous league, but also in trouble because a lot of patients start writing the email, sir, my mother is dying, I'm ready to take your drugs. If it is available? No, drug is not available. To develop a drugs, you need another 10 years of the life, 15 years of the life. It go to FDA, it go to the human trial, animal trials, all those sort of things. We are very earlier. And then we join with the cancer drugs. Then I say, okay, let us move fast. And the fast way is there. Another lady who is the expert in the ovarian cancer in the things. And then we got AcSIR grant as well. 1 million is IICTs over there. And these collaboratory starts. And I took the gold maps, because the chemic is associated with the gold, world laboratories. Why not? The idea was there to make the difference, to serve the peoples. The idea was there not to protect the IP to myself. No. Idea was very clear in my mind. I'm going to serve the peoples. It's clearly. That is one example. Second examples, come to the nanotechnology, is in there. Building with bubbles. We discovered methods by producing the hydrogen bubbles on the cathodes, electrodes, we can generate a very high surface area materials. Is a materials chemistry completely. Not only that, we did a lot of work in this area, and we also developed the gold nano spikes over there in this one, which is very selective. I block all the faces except 111. I'm talking about science here. Gold 111 exists, is in there too, and I create those surfaces, nano spikes, and those nano spikes I loaded on the QPM crystals. Now we are talking about translation research, right? After using the QPM crystals, we are talking about sensings. We can sense the pollution in the airs. And about the pollutions was there is the mercury. Because mercury is always affinate to the gold, we said that, okay, can we do that? Is in there too. So gold and nano spikes, just a simple one. And then you can see gold spikes over there. These mercury vapors are going. And as you can see, as you drop there is a QPM, the quartz balance works on there, the mass balance over there, and is very, very sensitive. We're talking about hundreds megahertz per second is in there too. And then once the mercury goes out, it goes back. Perfect scenario to develop a sensor for the mercury in the air. In Delhi, you have a thermal power stations over there, which burns the coal. Coal contains mercury. Mercury is a neurotoxins. Mercury make the people very sick. mercury is very bad for the pregnant women because it can retardate babies are born having the mercury in the fish. Isn't there? Very well known. So that is the reasons we did that too. And then we tested that in the laboratories for 6 months for trial over there. Then you can say up to different location, it is very sensitive to the how much mercury is coming in the air, and go back if there is no mercury. Perfect sensor. Do you understand the sensor? I believe you do. Like for example, somebody uses perfumes over there, and you are passing by there, she is using Zidor. And once the person gone out, smell goes out. Same things, is mercury is coming. When the mercury comes, the drop. When the mercury goes out from there, back to the normal. And computer is watching it. Computer is telling you that yes, at 2 o'clock, mercury level was very high. I mean, this is good for your measurement. You are the measurement laboratories. Isn't there too? And that goes in there. And that's what I'm telling. And again, all of a sudden, once we develop that, the world is talking to us straightway. Every media, everything, every newspapers, and we call it sometimes the Midas touch. It's a gold touch. We becomes, all of a sudden, within 5 years, the world leaders in mercury sensings. There is hardly any paper published in the world on the mercury sensings or mercury abatement which does not come to us. We wrote the books, we wrote papers, and we have a patent, number of patents, and not only that, we develop a device for there too. So you can see the QCM crystals over there, you can see a device over there too. And nowadays, we provide to the industries all the problems, any mercury related problems in the world. We have a capacity, we have a capabilities to solve that problems. We call it solution engineerings. You know why I'm talking to you, these guys? These guys are the examples of the solution engineerings. Is in there. One after that, I show you molecular engineering, I use solution engineering. And the story continues. I recently wrote a book to the Nature Springers, additive manufacturing, because additive manufacturing is coming fast in the world. It's the first book of its own kind in chemical science, in chemical engineering. And the book has a lot of features. There is a DOI there. You can always hit the DOI, you can download the books. It's not a problem. But most importantly, the book is dedicated to all those students who become orphan. Their parents passed away during COVID. This book was written during COVID. Neither I'm the editor-in-chief, neither of the editors nor the authors will not take even a single cent out of the book. Book as a hit. 2,500 copies were sold in 4 weeks. The Nature editors, he told me, Suresh, he rang me, Suresh, what is it? We never see such a book hitting the market. Book will be launched in IIT Bombay as well. There is author in IIT Bombay in there. It will be launched in there, but it has gone everywhere. I am so happy because this book, any penny which will be coming over there will go to those students, and there is about 8.6 million students who lost their parents in this world due to the COVID. They become orphans. See? Again, that makes a difference. I'm keep talking to you. What makes the difference? What you do, whatever you do, must make a difference. Is in there too. And that's another thing when we talking about additive manufacturing. You see, I was very pleased to say that is the additive manufacturing goes into dentistry. I was talking to you is there too. And why this idea came to in my mind, because all of a sudden I have tooth problems. Few days ago, I cracked my crowns over there, and I have to run to the dentist. And the dentist use in Delhi additive manufacturing. Funny. I say, wow, that's advanced, very advanced. But then I did the history. Additive manufacturing has been used in dentistry. First of all, in this Discover, you can see the difference. The additive manufacturing can build your crown perfect, absolutely perfect. All those old techniques of ringing and dinging and not fitting in there, gone. You can have perfect things is in there too, as you can see over there. And that is the dentistry's Santosh Dental's clinic in the Vasant Kunj. When I went there, he did the 3D printings in my mouth, is scanning over there. Next day, the crown on the plate, perfect fittings. I have no problem, no pain, nothing at all. No, zero. Nothing adjustment, nothing else. Perfectly adjusted. So guys, good to see that my motherland is adopted the state-of-the-art technologies in their business. Because that will make the difference, isn't it? Because that will make the difference. If any technology, any discovery, any science can help you in the life or reduce the pain, worth it. Isn't it worth it? That's what I'm telling you. I show you a little videos if I can. I don't know. I will try. Say that.
As long as
How it is made.
losing teeth, they've been replacing them with some form of denture. The first dentures were crude and made from gold and animal teeth. Fortunately, as dental science has improved, so have dentures. Following advancements in technology, the newest form of dentures are created with a 3D printer and programmable acrylic resins. First, impressions are taken of the patient's mouth. These impressions are later used as molds to create a stone model identical to the upper and lower jaws of the patient. This wax block ensures the lower jaw is positioned correctly and will be used as a guide when positioning the teeth later on. The models, along with the wax, are scanned in a high-tech scanner. These scanners are highly precise and accurate, scanning at a microscopic resolution. This level of precision ensures that the finished product will fit perfectly and be as accurate and comfortable as possible. Now, the process of digitally designing the denture can begin. Using specialized software, the designer will make sure that all the teeth will mesh together comfortably and naturally in the mouth.
See, all your things can do it by computer, just on your things.
Can be fabricated.
They're scanning the mouth completely, and with the help they do it.
Very specialized programmable acrylic resin. There are many different resins to choose from, depending on the final color desired for the teeth and gums. Once the appropriate shade is selected, the printing can begin. The dentures are printed on a high-tech carbon 3D printer. The carbon printer uses a very precise ultraviolet projector to cure the resin exactly where desired. This is one of the only 3D printers that can reproduce the level of fine detail maintained throughout the process. The denture base and the denture teeth are printed separately, using the same procedure, but a different resin.
Okay, so you can see that those things can be created. Fascinating, isn't it? How the technology can be translated into the real world applications. That is the things I wanted to show you, is in there. Now the third things, I'm now showing a model which I created with the help of the AcSIR. Then most of the universities nowadays, when they're collaborating with the different countries, there is always a collaboration between one-to-one, isn't it? One-to-one. Like Monash University with IIT Bombay, University of Queensland in Australia, IIT Delhi. But this collaboration is touching. I'm connecting my university with the whole India through the network of the AcSIR, CSR labs. It's a unique model. Nobody has thought it. Somebody called me is a SB models with my names. That's Suresh, this model. This model has been applied by 12 universities around the globe. Is there nothing wrong with there? The important thing is there, this model is connecting my country people, different labs. It provides diversity because CSR labs exist from Jammu and Kashmir to Kanyakumari, isn't it? It provides opportunity for me to serve everyone from this country, whether it's Assam, whether it's Bengal, whether it's Delhi, whether it's Hyderabad, whether it's Chennai, or whether it's Jammu and Kashmir. Every students who are coming with their own culture, with their own diversity, can work to the global platforms. See the advantage of that too. They comes with the diversity. When I meet these people in RMIT, I see the girls from Assam, I see the girls from Bengal, I see the girls from Bombay, I see the boys, from NPL is the highest one at the moment in RMIT, thank you, is in there too. So that's why I see all those peoples over there. What they get, what they do, well, that depends upon your programs. But I'm talking about the models. The one thing which is left over here, which I will be introducing the second phase, is bringing the industries over there. Professor Dhar told me that a lot of other institutions like Max Health, they are also joining it. Max Health is working with our anti-cancers, so they will join the program as well. Hospitals are joining. Industry, once we haven't exposed these programs to many peoples, many industries. But once we expose to the industries, I did expose to Australia, and those two students who worked there, they work with CSRO for sure. We can expose to that too. This model has a lot of potential. This model provide you peoples, the students, ample opportunities what you can do with your 4 years of the life. If you have a dream to discover something, if you have a dream to learn how the other part of the world operate, if you want to become innovators, if you want to become an entrepreneur, if you want to become some things that take my product to the marketplace, what can I do? What can I make a difference? Yes, this provides an opportunity. That's why I call it that our sustainability depends upon the trust. That's again is the trust. What I did, I developed the trust with the AcSIR peoples. I have a pleasure to develop the trust from the founder, Professor Brahmachari and Dr. Michelkers. He signed this. He's my mentor as well, by the way. He's the man who taught me about the innovation, the man who taught me about so many things. He taught me. My job is to implement them. I am an implementer. I'm a doer. Right? I'm not chief. I'm Indians. I'm more than proud to be Indians. I want to do the things on the ground levels. Because there is no point of establishing or announcing anything until it is implemented successfully up to A to Z. That is the point. That makes the difference. Again, I'm using this word now probably 5th times. That makes the difference. And that is what things. And for you guys, remember one thing, and I heard this word so many times, be passionate. Because that is the problems, in Australia as well. When you go to guys, to anybody, how are you? I'm okay. What do you mean by okay? See, what do you mean by okay? I'm okay. When you love it, you will fight for it. You will work harder for it. You will want to make sure it is perfect. Knowing that details matters, you will inspire everyone working on that project to share your passion. That's why I'm doing it. Life example to you. Isn't it? Same things. If you keep the bar low, you will never be great. Again, okay is the enemy of the greatness. Your passion is the key of your success. Translate. Don't tell many times to your boss, to everybody else, I have to do it. No, you love to do it. And that's the difference. Is a tendency of the mindset to criticize anything. Is a tendency of the mind to say the glass is half full. Why don't you see the glass is glass is half empty. Why don't you see the glass full, half full as well? See positivity in there? To criticize system, to criticize somebody, to criticize your supervisor, you criticize anybody, damn easy. It doesn't cost anything. But to make the difference, to accept that challenge, because I told you, the great peoples, they never cry, they try. The great peoples, they don't go through, they grow through. The great peoples are not born in the maternity ward. They are become great by their choice. Remember? So all those things, you can follow it. There is nothing wrong with that. Nothing wrong with that is there too. And I tell you again, share with you, what is the secret of the success? It is your attitude. It is your attitude which makes you difference. Because 90% whatever we want to becomes, whenever you give up yourself, you are the biggest enemy of yourself. Because it will be you. I can't do it. It is you. You will say, no, it is not me. Who is asking you? You are telling to yourself, I can't do. You become the failure or the first instance. I can't do it. Once you decided you can't do it, you will never be able to do it because you're out anyway. You're out. Because you accepted the defeat already. No, I can't do it. Why? Why can't you do it? It's your life, isn't it? It's your choice, isn't it? And that is the difference I want you to make as my countrymen. I told you, and I repeat again, the same phrase. My greatest strength is I love my peoples. And my weakness is I love them too much. Nothing wrong with that. I do. So I love you all. It's no question at all. And I want to show you one thing. I again differentiate. And again, I can show you if it works now. If I can show you is in there. Show that how this scheme was created over there. And if it works there, I don't know. Now it's not connecting the YouTube, I think. Can anybody help you? Cable connected? Wi-Fi? Oh yes, Wi-Fi we have to connect. That's correct. It's connected now? No? Yes? No. It's not Wi-Fi, is not connected. Anyway, you can download that if you go to the YouTube sometimes and go to the Academic Sharp Brain. This event was created in Melbourne with the presence of 3 Nobel laureates over there, is in there. It's worth looking there. When I'm inviting about 8 or 9 top students, young scientists, to present your discoveries to the best people of the industries and the best peoples of the academics, and asking them, do you want to take my research from here? Do you want to support me? Again, the idea was there not to get a money, to get a grant. Yes, if you can get it worthwhile, but to develop an attitude that I'm not looking for a job. I will create a job. Why not? Many people have done in the world. Again, I tell you, because you decided, I can't do it. You can't do it. You decide that I can't do it. You can't do it. But someone, you saw the Google do that, who discovered that? Microsoft, Hotmail, who discovered that? Find out, look at it. And then you decided, no, I can't be then. Why? Why can't you be then? You can be then. And that's why I'm telling you. And that's why I think it is not coming. So, remember one thing. When I become we, even the illness become wellness, isn't it? And then I say, alone, if you are alone, if you look in your box, I can say, but together we can talk. Isn't there? Alone, I can enjoy, but together we can celebrate. Alone, I can smile, but together we can laugh. Your choice. And that is the beauty of trustworthy partnerships. And I say it again, when I become we, even illness become wellness. I am the follower from my student lives of this saint. I heard about him, I read about him, and I always remember. That is the program at the Genius, one you can see, is the Academic Sharp Brains programs. Look at it on the videos, on the YouTubes if you can. Unfortunately, it's not connected. The Wi-Fi probably is not coming there too. But then I always believe the life is a great chance. That's why I'm telling you guys, the life is a great chance, or your 4 years of the PhD is the greatest times of your life. Remember one thing. It's the best times where you're full of energy. Right? Full of the mind, full of a passion to do something different is in there too. Seek for the highest, aim at the highest, and you shall reach the highest. I would like to take this advantage to warmest thoughts, because probably I won't see you. Christmas is the Diwali of Australia, you can say that. is in there. So I'll be missing because I'll be here in India during Christmas. So warmest thoughts and best wishes to wonderful holidays and Happy New Year's. It is coming. That is there. And what the New Year brings to you will depends the whole a lot what you brings to the New Year's. Right? Important thing is there. Merry Christmas and Happy New Year's. Thank you. Well, I'm more than happy to take your any comments and questions openly, without any fear. So please speak up. So either you understand everything or you do not understand anything at all. There are two things there, right? But is there any question in your mind? The talk was not designed to make a particularly breakthrough of the science. Talk is designed to take you how the science can make a difference in the people's life. I gave you some certain examples, which I believe they are proven examples because I've done it, is in there. Now, choice is yours, always.
Thank you, sir, for your golden words. Your words were highly motivating and extremely informative. It was an honor to hear from you, sir. Thank you so much for your valuable time and words. May I now request Professor Venugopal Achanta, Director CSIR NPL, to honor the speaker with token of gratitude.
Just completed our 75 years.
Wow. I think I should take this one out. Just a minute.
This is a commemorative stamp in the cover.
Sir, we also request you to honor Director ACSIR, Professor Ajay Dhar, with token of thanks. Thank you, sir. Now, I request Professor Reena Sharma to deliver the vote of thanks.
Wow, what a talk we heard. So inspiring, so motivating. So, respected Professor Suresh, Professor Dhar, Professor Venugopalachanta, and our esteemed colleagues, guests, and students. It's my pleasure to be standing here to propose vote of thanks on behalf of my ACSIR NPL, CSIR NPL, and on behalf of all of my colleagues. On behalf of all of us, first of all of us express our gratitude towards the builder of this laboratory, as we call him, builder or visionary of this laboratory, that is Sir K.S. Krishnan. He was the visionary. It was his vision that he took us to the level of being premier physics laboratory as well as excellent material science research laboratory, doing environmental sciences also, and it was during his time that India signed Meter Convention Treaty, and NPL was designated to represent India at BIPM, and we became member of that. And I think this visionary realized very well, which we are still struggling to combine all these fields to develop new standards and have a mark or flagship in the arena of international standards. Because any standards discovery, establishing his standards is one thing. All standards discovery is based on excellent basic science. So what better tribute we can give him other than working in these fields together and respecting each of these fields equally, be it standards, be it basic sciences, be it applied sciences, and be it our environmental sciences. So our heartfelt tribute to Professor K. Krishnan. And then I would like to express my deep sense of gratitude to our speaker, distinguished Professor Suresh today. You have, sir, spared your time, and you are here, and I think your speech was contagious. You will infect us with passion. Our students, I believe, will be infected so much that it will ignite passion in them, and they will be having attitude to make difference. I hope you will be, with this, you will be at least inspired to get that attitude so that you can make difference by your research and not depending on grants and other things. So thank you very much, sir, for being here and infecting our students with this contagious disease of passion. This is what I say. If they get at least 10% of the passion and attitude you have done, you have given them a good glimpse of your fascinating world of gold chemistry, which is having applications right from medicine to sensors and all. I think you will be motivated to do good science after hearing him. So thank you very much. And I would like to express my profound gratitude to both the directors, Director CSIR NPL and Director ACSIR, that is Professor Venugopal Achinta and Professor Ajay Dhar, for giving us, at least me, the guidance always and for encouraging to do better than ever before. So it is your support that is our treasure, and we keep drawing from it little bit, and doing whatever good we can do. Since I took over as a ACSIR NPL coordinator in 2018 December, Dr. Dhar has been my guiding factor, and any problem of the students in any way, wherever, whatever bureaucracy is coming into the picture from ACSR side, he has been very kind to help us in solving that. And that is how we say he is our ambassador and our support system at ACSR. He has always helped us, first as Associate Director, ACSR, and now as Director ACSR. Thank you, sir, for your kind support. And since Professor Venugopal Achinta has taken over as Director of NPL, when he came, we had first student interaction with a long list of problems that we were having for years together and trying to solve little bit. Now, I'm happy to say that most of them have been solved. He is very keen to help his students. He is very keen to motivate them. He somehow finds time to listen to even their scientific presentations and giving them scientific and technological advice, besides helping them in solving problem as a science administrator, that is Director of NPL. Thank you, sir. Thank you very much. NPL has been very fortunate to get you here and to get all the guidance from you. Thank you. And I'm thankful to my organizing team here. I'm thankful to my senior colleague, Dr. Dhakate, Dr. Ritu Srivastava, logistic supports from that is auditorium, be it cafeteria, be it civil work section, be it horticulture. Everybody helped us wholeheartedly and timely. And sincere thanks to our ACSIR team led by Arpita Sen. Of course, Dr. Dhar is there, Mrs. Arpita, and also Ashwini, and all the members of the team. And Soma is a cusp between the two, and my HRD team. All of them, thank you very much. And thanks to all those who were directly or indirectly involved in the program. You can see beautiful rangoli done by students, Rashmi and other students. Rashi Kedia is helping us. So thank you all the students. Thank you all the faculty. And last but not the least, great thanks to you who have come in large number here, who you have taken time, and you are here, and that's why this program is a success. So thank you all. Please give it a big hand for yourself at least. Thank you. And now I think refreshment will be distributed on the seat, and then we will be having a cup of tea outside the lawns. Thank you.